me about kinetic energy in an inelastic equation?
It loses the kinetic energy.
Yeah, okay, pretty close. In an elastic collision, we know that kinetic energy is conserved. Okay, so it's the same before as it is after. In an inelastic collision, kinetic energy is not conserved. Okay, what happens in these inelastic collisions is when two things combine, there's a transfer of energy. Okay, we know that energy cannot be created or destroyed, so there's not really a loss of energy, but we can say there's a transfer. Okay, it becomes thermal energy or different types of energy that could be given off. Okay, so it might bring about some new form of energy that's not kinetic. All right. So when two things collide in an inelastic collision, it's transformed into thermal and other minor types of energy. What we're going to do today is we're going to be able to calculate the amount of energy that's lost, okay, and I say that in quotations because energy is not truly lost, it's just transformed into another type, okay, so we're going to look at the amount of kinetic energy that is transformed after a collision, okay, or post-collision. All right, so the problem that we're going to look at with inelastic collisions and energy is the same problem we looked at originally when we looked at inelastic collisions. So if you want to look back at your notes a little bit, it's the one that has the two trains that combine, and we solve for the final velocity of those trains after they combine and stuck together. Okay, so if you want to take a look back at that example in your notes, kind of get refreshed, that's what we're going to look at here in terms of kinetic energy transfer. All right. So if we go back to our inelastic train collision, we had the little red train that came in and attached to the blue train, and we found the final velocity just using our inelastic equation. Okay, but now we're going to look at it in terms of kinetic energy, not just in terms of velocity here. All right, if we think about our inelastic collisions and what actually happens here, and we're talking about kinetic energy, we're going to use this equation. Oops. 1/2 m1 v1 squared plus 1/2 m2 v2 squared. All right, remember 1/2 m1 v1 or 1/2 mv squared, that's a kinetic energy equation. So here's our first object on the left and our second object on the right. All of that's going to be equal to 1/2 both the masses added together, so m1 plus m2. And all that's going to be v prime squared. Okay, that's the equation that we're using here to look at kinetic energy. All right, so what this is saying is that kinetic energy on the left or before this collision would equal kinetic energy on the right. However, we know for an inelastic collision that's not true. Okay, we know that there's some sort of transfer of energy. So there's going to be some other form of energy here that we don't know that we have to add to this final kinetic energy to make it equal to our initial. Okay, so we're going to be able to solve for this other type of energy, this amount of other energy that's been transformed. All right, so we can go ahead and start plugging in some numbers here. So if we take 1/2, both these trains had a mass of 10,000. What was our initial velocity for this first train? Yeah, so it's going to be 24 squared. Okay, so then we're going to take our second object. Its velocity was what? 0. Good, so we'll take that. 1/2 times both the masses, which would be 20,000. What was our final velocity? We solved for that in our initial problem. It was 12. Okay, it was half. So 12 squared. And then we're going to have some other form of energy here, which is what we're solving for. Okay, this is the amount of energy that's been transferred or transformed into a different type. So this E right here is what we're going to be solving for. All right, so we should on the left side, I think, get about 2.88 times 10 to the 6th, or something pretty close to that. On the right side, by combining this term, we should get about 1.44 times 10 to the 6th, and then this says plus E here, even though you can't really see it. So this is our other type of energy that it's been transformed to. To solve for E, then we should subtract over the 1.44 times 10 to the 6th. And that means the amount of energy that's been transformed should also be 1.44 times 10 to the 6th. Okay, and what's our units for energy? Joules. Yeah, joules. Okay. So this number right here tells us that when these two trains collided and stuck together and continued their path, they lost half the kinetic energy that they began with. Okay, so they lost half of it. This is what they had initially, this 2.88 times 10 to the 6th. This is what they had finally between the two of them. This 1.88 times 10 to the 6th, or 1.44 times 10 to the 6th, half of that energy was transformed into something else. Okay, it was... These relationships are really clear when the masses of these two objects are the same. Okay, so that makes the relationship pretty clear. Okay, what questions do you have? So this is giving us kind of a picture of what's going on in this collision. I'm going to give you a couple minutes to get it written down, get your head kind of wrapped around it, and then we'll start on the math. Okay, so what's happening here is that two pucks collide as shown in this diagram. This one's moving to the right at 2.4. This one's sitting still. After the collision, they rebound off each other, one going this direction and one going this direction. Okay, so I'm going to give you a couple minutes to kind of get it written down, get thinking about it, and then we'll start making our list and doing the math that goes with it. Okay, when we deal with things in 2D, we don't like working with angles, right? We have to break them down into components. All right, so what do we see here that we need to break down into components? What about this one? Okay, this is v sub 1 prime, which means it's the velocity of the first object. What's the prime mean? Yeah, after the collision or post-collision, okay? So let's kind of talk about what we have so far. Our first object is moving only to the right at 2.4 meters per second, so it only has a horizontal component. Our second object is sitting still, so it has neither a vertical or a horizontal component. Okay, are we clear so far with that? Okay, post-collision, each of these objects has both components. So we've got to break this down. We're going to look at our momentum now just in terms of horizontal or vertical. Okay, and then we're going to be able to combine it back and look at our entire post-collision speed. All right, so I'm going to individually clear this screen off, so get what you need from it now. But we're going to go ahead and break down this first vector here. All right, so our v sub 1 prime means our speed of our first object post-collision. We need to break that down into x and to y. So if I break these down, what would the name of this side of my triangle be? What subscripts do you think it might need to have? Okay. So v sub 1, because that's our initial or our first object. So v sub 1, x or y? X, and then it's prime because it's post-collision. So then that means this side of our triangle would need to be called what? V sub 1, y prime. Okay, and I know this seems like a lot of subscripts and a lot of letters attached to these variables, but they each have a meaning. Okay, so I need you to understand what the meaning behind each of these subscript is. The 1 tells us it's the first object, the x or the y tells us as direction, and the prime tells us that it's post-collision, so it's after, okay, or final. All right, so let's go ahead and break these down. We'll solve for v sub 1 x prime first. V sub 1 x prime. If we want to solve for that, we're going to take our hypotenuse times sine or cosine. V sub 1 x is adjacent to this angle, which means we need to use cosine. Okay, because we're using the adjacent and the hypotenuse. So we'll take 1.8 times cosine of 30, and that gives us what? 1.55. Okay, is it going in the positive direction or the negative direction? It's going in the positive direction.
You hit on your calculator to change it to...
So let's go ahead and solve for v sub 1 y prime. To solve for that, we'll take 1.8 times sine of 30. And that gives us 0.9. All right. So are there any other vectors here that we need to break down into components? What'd you say? This one right here? this is what we're going to be solving for. So we're going to solve for both of these components. V sub 2 y prime, and we're going to solve for v sub 2 x prime. Okay? That's going to be able to allow us to solve for the velocity of our second object here, which is our overall goal. All right, so I'm going to clear this off, give myself a new screen. Do we have everything we need to from this slide? Yes? Okay. All right, so let's go ahead and start compiling our list of what we need here. Okay, tell me what we know from our object. Yes?
Well, we know the v sub 1x, like, beginning.
Okay, we know both of those. So let's go ahead and just start from the beginning. The mass of our first object is what? 0.5. Okay, what's the velocity initial of our first object? 2.4. Is it horizontal or vertical? Horizontal. So I'm just going to put a little arrow there so I know that it's only a horizontal. Okay, it doesn't have any vertical components. What's the mass of our second object? 0.3. And the velocity of our second object before the collision? 0. So it'll be 0, x and y. All right? So now we can start using our elastic collision equation. All right? We're going to look at momentum of these objects only horizontally or only vertically. Okay? So we're going to start with our horizontal. So we'll solve for momentum just in the x direction right now. Okay? I want to keep this pretty organized, so we have to make sure that we label our x and our y's very clearly. All right, so let's start with momentum in the x direction. And our equation we use is m1v1 plus m2v2 equals m1v1 prime, m2v2 prime. Okay, we know that's what we're working with here, right? Momentum. P is momentum. X is just means it's in the x direction. Okay, so we're solving for a momentum equation here. Our elastic momentum, m1v1 plus m2v2. Okay, would equal m1v1 prime plus m2v2 prime. All right, this is only going to be in the x direction here. So let's go ahead and start getting some numbers plugged in. Our m1 is 0.5. Our m2, or our v2, our v1 is only in the x direction or only in the y direction? X. That means we can plug it in here for momentum x. So we'll take our 2.4. Our second mass is 0.3. What about our second velocity?
0.
Just 0. All right? M1 doesn't change, so that's still going to be the 0.5. So this V1 prime in the x direction, we solved for that already right here. All right, so we're going to go ahead and plug that in, our 1.55. And our M2 we know doesn't change. We're going to solve for V sub 2 x prime. All right, so tell me what we're getting here on the left side of our equation. 1.2. Okay, and that's going to equal, what's this term right here give us? Okay, so we're going to subtract that 0.775 over, divide by 0.3, which gives us a v sub 2x prime of what? 1.42. Okay, so which direction is this in? To the right. Yeah, it's horizontal and it's in the horizontal positive, so that means it should be going right. Okay? So we can put a little arrow there just to help us out. Now let's solve for the momentum in the y direction. Yep, we're going to use the same equation. We're going to have to plug in numbers a little differently. Okay? So I'm going to get rid of this over here. So the mass of our first object does not change. Do we have any velocity initially for the first object in the y direction? No. Okay, so it's 0. We know our second object's at rest initially, so that's also going to be 0. Post-collision, our v sub 1 y prime we solved for, and we know it's what? 0.9. Okay, that's what we solved for over here from our original picture. And it was going up, so that means it's in the positive direction. And this is v sub 2 y prime, even though I can't barely fit it in there. That's what it should say. Okay, v sub 2 y prime. So this whole left side will equal 0. Once we get to this step, we make sure we subtract over the 0.45. Okay, and that'll give us a v sub 2 y prime of what? Good, negative 1.5 meters per second. Okay, so this negative tells us that it's going in which direction? Down. Down, because we're looking in the y. Okay, we're looking at the vertical components, and if it has a negative for the y, it's going to be going downward. So we're almost there. Now we have both of our components of our final velocity vector. We need to do Pythagorean theorem and second tangent now to find our actual resultant, okay, or our hypotenuse of that triangle, and we need to find the angle from which the origin it's flying or colliding or moving, whatever you want to say. Okay, so we'll start here. Our x direction is to the right. Our y direction is down, so 1.5, and this is 1.42. Here's our origin right here. That means we need to find our resultant, which would be v2 prime. Okay, because these are components of v sub 2. This is v sub 2 y prime and v sub 2 x prime. So those components make up our second velocity of our object. So if we want to solve for v sub 2 prime, we should be using Pythagorean theorem between 1.42 and 1.5, and what do we get? 2.1, and it's a velocity, so it's still meters per second. Okay, and it's going to be at what direction? South of east, what degree? 47 degrees south of east. Okay, so the way we find our angle right here, the way we find this theta, is we'll take second tangent of the opposite side, the 1.5, second tangent of opposite over adjacent, okay, as compared to this angle from our origin. So second tangent of 1.5 over 1.42, that will give us our angle, which says 47 degrees south of east. So this is an elastic problem where one object breaks apart into multiples. Okay, so instead of having a collision like we think of as a collision, we're going to have two objects that break apart into two new. Okay, so we begin now with one object and we end up with two. Okay, so it's kind of like a reverse inelastic equation, although it's not the same necessarily principle behind it. And there's some clues already attached here a little bit. Since we know the mass of this fragment is 5 kilograms, that means the mass of this fragment must be 2 kilograms. Okay, so we've kind of labeled them here as m sub 1 and m sub 2. All right, so what we know from this problem is that our mass of basically 1 and 2 is going to be 7 kilograms. And you don't have to write it like that. You could just write it as mass if you want. However you want to think of it is fine. But this is the mass of both of our objects put together. Okay, and its velocity is 12 meters per second, and it's to the right. Okay, so it's going to be only a horizontal component. If we look at them post-collision, the mass of the first object we said was 5 kilograms. And what was the mass of that object after the collision, or what was the velocity of that object after the collision? Good. So it was 15 meters per second south, which makes it a negative 15. Okay? And is that going to be a y or an x? It will be a y. All right? The second fragment that we have is 2 kilograms. And we know that its velocity post-collision is what we're solving for. Okay, and since its velocity after the collision was at an angle, we know that we're really going to have to solve for v sub 2 x prime and v sub 2 y prime to get there. Okay, so I'm just showing you, in order to get to this v sub 2 prime, we're going to have to solve for both of the components. All right? Are we clear so far? Okay, let's go ahead and start solving for our x components then. Okay, this symbol, this thing where I'm doing right here makes no difference. Okay, this is just for me to keep it organized so that I know these are all x, the other ones are all y. This is not some secret mathematical symbol that you don't know about. Okay, that doesn't mean anything. It's just my way to keep it organized. Are we good? Okay. So the mass of our total object on the left, or the initial side, is going to be 7 kilograms, and its horizontal velocity was 12. Okay, and that's it. That's the only object we have. If you wanted to list it as a 5 kilogram object moving 12 meters per second plus a 2 kilogram object moving 12 meters per second, you could do it like that. It's going to give you this exact same answer. Okay? So post-collision now we have a 5 kilogram object. Does it have any horizontal velocity? No, because it's moving negative 15 meters per second or south. Okay? Our second object, our 2 kilogram object, we want to solve for its velocity in the horizontal direction. So we're going to solve for v sub 2 x prime in this equation. Okay, so to get v sub 2 x prime by itself, we'll divide by 2. And that means our x component of that velocity is going to be 42 meters per second. Okay, that's just the x component. We're not done with our problem here. Only the x. So now we'll go ahead and solve for our y. Does our object have any y velocity at the beginning? No. So now we know that the initial object has no vertical velocity, so that's our 0 plugged in there. Our 5 kilogram object has a negative 15 vertical velocity. Oh, I'm writing too big. And our 2 kilogram object, we want to solve for v sub 2 y prime. Okay, when we add this 75 over, we make sure it becomes positive. We'll divide by 2, and we'll say our v sub 2 y prime is going to equal 37.5 meters per second. Since it comes out positive, that means what direction is it going in? Yeah, up. It's going up. Okay, which is what our picture looked like. If we think about what our picture looked like if we can go back one, you can see that that fragment is flying upward, okay, to the north and to the east. So now let's go ahead and draw our resultant. Here's our origin. We'll go east first, and then we'll go north. So our north component was 37.5, and our east component was 42. We want to solve for our resultant, which is v sub 2 prime. We want to find that angle in there as well. So to find our v sub 2 prime, we need to take our Pythagorean theorem of 42 and 37.5, which gives us what? What speed or what magnitude? 56.3 meters per second. And to find our direction, we need to take second tangent of 37.5 over 42, which gives us what degree? What did you say? 42 degrees?
Yeah.
And what direction? East then north, which means north of east. Okay, so go ahead and get it written down. Kind of get your head wrapped around what this question is asking, and we'll get through the math in a second. Okay, I'm going to go ahead and start just putting our list together here. Okay, in an inelastic equation, how many final velocities should we have, or post-collision velocities? Yeah, so we'll just have v sub prime, okay, that we're trying to solve for here. We'll still have to break it down into x and y, but we don't have a velocity for each object because they combine and become one. Okay, so let's go ahead and plug this into our inelastic. We'll start with our x. M1 times V1. Is our V1 an X component or a Y component? X, because it's going east. Okay, so M1 times V1. M2 is our velocity to horizontal or vertical? It's vertical, so that means we just have a 0. All right, here we're going to take our M1 plus our M2. So that's going to give us 1500 times our v prime. And it's going to be vx prime or vy prime here? Good, vx prime. That's what we're going to solve for in this particular part of it. Okay, so 900 times 12 is going to get us 10,800. And that's going to equal 1500 v sub x prime. When we divide that 1500 over, that means we get v sub x prime to equal what? Good. 7.2 meters per second. And since it's positive, that means we're going, to the right or east. Exactly. Okay, then let's solve for our y. M1 times V1. Does our V1 have any vertical component? Nope. Our M2, our V2 does have a vertical component. Is it positive or negative? Positive, because it's going north. And we're going to solve this time for v sub y prime, exactly. Okay, so our v sub y prime equals what? What'd you say? 9.6, and it's going to be in what direction? Yep, north or up. Okay, so now we have our components. All we do after that is build our new triangle, find our angle. Okay, so I'm going to try and kind of squeeze this in at the top up here. We need to go north and east, so we'll go east and then north. Our x component was 7.2. Our y component was 9.6. We want to solve for our resultant here, which would be v prime. All right, so using Pythagorean theorem and second tangent, we get our final answer to be 12 meters per second at 53 degrees.